Section 9.3, the derivative. So there are going to be two parts to this section. One is the average rate of change, and the other is going to be the instantaneous rate of change. The first part of the notes here is just really a graphical representation of the theory that is occurring behind ultimately determining the derivative of a function. So I do want you to scan through these, read through these, but I'm not going to spend time on the YouTube video here going over this in too much depth. I'm actually just going to basically cut to the chase and get to the examples because that's really what you want to know. Now, with that being said, this is our expression for the average rate of change, and it should look familiar to you. This is also called the difference quotient, which is something we discussed in Math 128. I will also tell you that another way to look at the average rate of change is to look at this expression, f of b minus f of a all over b minus a. This is probably an easier way of looking at this expression. If you're given 2 points on the graph of a curve, okay, so 1 point on the graph of the curve would be a comma f of a. This would be the x value, this would be the y value, and the other point then would be b comma f of b. Again, x value, y value. Okay, so these are the 2 points on the graph of a given curve. Okay. We'll look at an example of this at the end. Okay, that's average rate of change. Moving on. The next part is, well, what if that denominator approaches 0? This notation should look familiar to us. This is now going to the concept of limit. All right. So if that is true, what would you get? And I want you to scan through these, pause the video if needed. Remember, you can download these notes. So just go to lessons, and they're right there for you. So ultimately, what we're going to do here is look at this limit. And this limit is actually going to give us the derivative of f at x. All right, so this is the big thing you want to know. This is huge. This is one of the most powerful things we have in all of mathematics, actually. This is read as f prime, like Optimus Prime. F prime of x is equal to the limit of the difference quotient as h approaches 0. Okay, we'll be looking at this in our first 3 examples today, okay? Other notations for the derivative that may come up, you could have the derivative with respect to x of the function f of x, dy dx, or y prime. Again, this little apostrophe here means you're looking at the first derivative, and you say it as prime, so f prime of x, y prime. All right, let's look at some examples. Example number 1. Use the 4-step process to find the slope of the tangent line. So that's instantaneous rate of change now. That's the first derivative. To the graph of the given function at any point. So let's go ahead. 4-step process. Step number 1. And again, ultimately, what we're going to be determining here is what's called f prime of x, or the first derivative of x. So the first derivative of the function f of x. So this is what we're trying to determine right there, ultimately, right there. So we're going to use a 4-step process to accomplish that. So step number 1 is to determine this. What is f of x plus h? Well, remember from Math 128, function notation. What does this mean? Well, this means wherever you see an x in the original function, f of x, you're not going to be replacing every one of these with the quantity of x plus h. So it should look like this. Again, everywhere we initially had an x, it's now going to be the quantity of x plus h. Okay, and then from here you simplify this. So we get negative 5 times whatever this is squared. You got to do exponents first. So let's look at the quantity of x plus h squared. That's going to give us x squared plus 2xh plus h squared. And then we're going to distribute the 2 through. So that's 2x plus 2h. And then we're going to bring down the minus 8. And ultimately what we get here, after distributing the negative 5 through, is negative 5x squared minus 10xh minus 5h squared, and then bring everything else down. So plus 2x plus 2h minus 8. That's step 1. Determine f of x plus h. Step 2. Step 2 is to determine what f of x plus h, that's an h, minus f of x would look like. Okay? Notice this is now the numerator of the difference quotient. Okay? This is part of that limit we briefly looked at in the notes prior to this example. So, what does that look like? Well, just bring all of this down. Just like copy and paste it. So negative 5x squared minus 10xh minus 5h squared plus 2x plus 2h minus 8. This entire expression is f of x plus h. All right? This is the quantity f of x plus h. And then minus what? Minus whatever f of x is. So this is your f of x. So minus whatever f of x is equal to, which is negative 5x squared plus 2x minus 8. Okay? So now what we need to do is simplify. So we're going to distribute this negative through this quantity, and that'll be adding the opposite. So add the opposite, opposite, opposite. And let's see what we end up with. Well, the negative 5x squared plus 5x squared, that's now gone. The negative 10xh remains. Let's see what else. The negative 5h squared remains. Oh, the 2x, positive 2x, and the negative 2x, those are gone. The positive 2h, that stays. That's going to stay. And then finally, the negative 8 and the positive 8 also is eliminated. So look what just happened there. What just happened will happen every single time, okay? And that is every term that makes up the function f of x will be eliminated. That's going to happen every single time. And what else is going to be true every single time is that what you end up with here for this step 2, f of x plus h minus f of x, is going to be an expression in which every term contains at least one h. That will always be the case. In the third step, you're now going to be adding the denominator h. So what we're going to do to figure this out, which is now the difference quotient, is we're going to bring this down. Okay, this is our numerator of our difference quotient. And then we're going to divide this numerator by h. And so every single term in the numerator will be reduced by an h, right? H over h, gone. H squared over h leaves 1h, so on and so forth. So we end up with a negative 10x minus 5h plus 2. This is our difference quotient. All right, now, in calculus, we're going to add one more thing to this, and that's going to be determining what's called, again, the first derivative for us, or f prime of x. So let's do that now. Step 4 is to actually determine this, the first derivative of the function f. And that first derivative is going to be equal to this limit. The limit of what? The limit of the difference quotient. So the limit of this expression, which is our difference quotient, as what? As h approaches, supposed to be an arrow there, approaches 0. So all you have to do now at this point is see if it's possible to replace every h that exists here with a 0 using substitution. And do you end up with a nice algebraic expression? Yes, you do. If this h becomes a 0, then this expression is gone. And you're left with negative 10x plus 2. And this negative 10x plus 2, folks, is the first derivative of the function f. We just used a 4-step process to determine, or the definition of the first derivative to come up with this result.